Today's session, 7 super solutions. Growing, developing, and administrating Splunk at Murex. So, my name is Robert Lynch. This is the 3rd year in a row I've been speaking at .conf. 2 years ago, I was honored to win the Splunk Ninja Revolutionary Award. And this year, I was the Commander finalist. That I didn't actually win that one though, but next year I'll come back. So I work for a company called Murex. We took in Splunk 5 years ago, and what I'm going to do is I'm going to tell our story about how we've gone from 1 user to 100 users, and 7 of the major things we did to make users engage in the system and to help you as admins or developers, just so that you can grow the system and make it work for you, okay? So this is generally the gist of it, and hopefully when you leave, you can use a few of these when you go back home. This is the idea, okay? So, a quick forward-looking statement. Okay, hope you all got that. We're moving on to the agenda. So, the agenda for today is I'm going to do 3 slides on the introduction. So I'm going to tell you about my company, Murex. I'm going to tell you about who's using the system. I'm going to tell you what the problem was. And then I'm going to go into the 7 solutions for the problem, okay? So that's how it's going to work today. So who is Murex and what do we do? Murex is a financial IT company. We sell software to investment banks. So what does that mean? That means that, let's imagine you're a bank in New York and a trader is trying to buy 100,000 Japanese yen to a bank in Singapore. He needs to price that trade and he needs to book that trade. You need software to do this. Murex sell this software, okay? That's what we do as a company. We sell software. And this software goes into some of the biggest banks in the world and it's used for trading platforms, okay? What do I do specifically? I'm a non-functional tester. I'm a performance manager. So there's one thing that gets software removed from these big banks is bad performance. Let's imagine you have a trader, he's trying to trade, and suddenly it glitches. It takes 3 minutes to book a trade, and he lost the trade, so he's lost $1 million. He gets very angry very quick, and then the software gets replaced. So performance testing in financial IT, non-functional testing, is a big business, basically. You have to make sure these banks are happy, the platform, the software is fast, okay? So that's what Murex do. Do we do it well? Some people would say we're very good at it. So we win a lot of awards every year, and some people say that we're doing very good in our industry. We're 30 years around, okay? So now let's move on to, that was the problem. So the problem was we were doing big simulation tests for these big banks. So let's imagine a big bank in London. They buy Murex. It takes maybe 6 months to install the software because you have to configure it for their configuration. Every bank is different. Every bank has different traders, different risks. Like, it's not Microsoft Word. It's a very big enterprise platform that goes in, okay? When we do a test, we might be running a test on 10 machines, trying to do a stress test, so that when the bank on Monday morning turn their key on their new toy, and all the traders try this new platform, and they're trying to book trades through that new platform, the platform doesn't fall over, okay? So one of my major jobs is non-functional performance testing. Now, when you do that, you produce a lot of data, okay? You produce a lot of CPU data, garbage collection, network, internal source types, et cetera, et cetera. So 5 years ago, I took Splunk and I fixed problems for my team, okay? And then it became successful. I fixed it for the Dublin office. And then 3 years ago, the COO of Murex asked me, could I roll it out globally for all the different teams for test and development for our software. So we did that. So we have about 100 users now globally using the system, okay? I'm based in Dublin, Ireland. Beirut, I often go there we have a massive testing team in Beirut, and in Paris, a lot of our developers are there as well, okay? So that just gives you a quick flavor of who we are, Murex. What do? We make financial IT software. We had a problem of too much data. We got Splunk in, and this is the kind of use base that now use Splunk across the system, okay? So now we're going to get into the 7 different kind of problems and the 7 solutions we had to these problems. And I've grouped them into 3 categories. Growing, so how to kind of grow it. If you're the admin, if you're the person trying to convince people to go to Splunk, to give me your data. Don't go to Elasticsearch, come to me, because lots of places have different big data tools. Admin, if you're the administrator, okay? How not to waste your day doing little admin things. And then development, if you're a developer as well. So tricks on how to develop quickly and things like that, okay? So at Splunk, I do all of these. I kind of do A to Z of Splunk myself. And these are just kind of seven things that we've done. And what I have is, I have 7 videos as well illustrating. So it's not just dry slides. I'm going to give you 7 demos as well, okay? So number 1 is, where is my data? So we had a problem where we had all these hosts. Now imagine each host is a Bank London, Bank New York, Bank X. And they're testing development. The people are testing on these hosts, and they're going into these deep dive dashboards. It could be CPU, network, garbage collection, whatever, JSON, memory, et cetera, et cetera. And we had all our users looking at the deep dive dashboards. But one of the problems that kept coming to me very quickly was, Robbie, I can't see my data. Robbie, I can't see this, I can't see this. So I was spending my day trying to keep these people happy, but the data was there. They might have been just looking in the wrong place, or they didn't understand the system. And I said, I have to be able to make this go away, because I'm spending too much of my day doing these little micro checks. So what did we do? We made a consolidated dashboard, and we called it Splunk Home. And in Splunk Home, all the data from all our users and all our hosts. So imagine we have multiple test campaigns going on over multiple machines in the company, and all that data can now be visible from one page. Now you just get a high-level overview so that people can see, yes, my host of Bank London, I can see I am getting data. I don't need to link Robbie and say, hey, I can't see my data, et cetera, et cetera. So let's have a look. How does that look? So it's a 2-minute video. This is the home page. So you can see on the left-hand side, we can see data pulsing into the system, okay? And we can see these are all different hosts. This is a subset. We have about 7 or 8 hosts there pushing data into the system. The idea is that people can now see, oh, well, I'm host X, I'm host Y. Yes, I can see data coming to the system. On the right-hand side, now, sorry, it's a bit dark, is we can see the users globally using the system. Now this is just pure sales. I want people who log in to see that Splunk is being used inside the company. I want them to believe, hey, we have a system that's growing, and that giving me your data is a good thing. So it's kind of marketing as well. So we come down to the live data, and what we do now is we split it out per source type. Because sometimes people might say, well, I'm seeing data for, that's my host there. And they say, well, actually, I'm seeing data for source type X or source type Y, okay? So we have a situation now where they can see all the different source types, and they can see all the data coming in, okay, which is great. Then we get the email address per each source type. I've had to obviously black them out. And then what we do is we also get the location of each of these live environments over our global network. So it's all just general data that we found people wanted to use, okay? And this is generally what we saw. So there's the location there, and we said, oh, that's okay. But now, what if you want to do a deep dive into one of these data? Well, of course you can. So this whole dashboard now is now linked up to all the deep dive dashboards. So in this case, GC is garbage collection, Java garbage collection. So you click it, boom, it brings you straight into the garbage collection. And now that's a deep dive dashboard for that particular host of the London Bank. And now the people can see their data for the last 4 hours there, okay? Now, I'm not here to show you these dashboards. I really want to just focus on, this is the home solution, okay? And that's the deep dive for the live environment, okay? So it's one central place where all the data of all the systems come into one place. So people can now see, is my forwarder down? Is it up? Is it pulsing data to me? And the answer in this particular case is yes, okay? So this was a good way to stop people asking me, hey, I can't see my data, Robbie. You know, I just made a nice, sexy homepage, and now everyone, this is the entry point for Splunk. Everyone comes in here, okay? They don't go to the deep dives, they come here, and then from there they can jump on if they wish, okay? So what was the problem? I was getting too many emails about little things about not being able to see my data. The solution, create one location where all data can be found, okay? That's number 1. Number 2, fast forward of deployment. So 5 years ago when I started with Splunk, I was manually deploying all the forwarders because I wanted people, I had to convince people to take Splunk. I had to say, oh no, it's a good system, take it. You're trying to sell yourself. So I would go around and I would put on the forwarders on all the hosts. So they're doing all the testing, and I would manually put on all the forwarders, okay? So we didn't get professional services. I just had to upskill, learn it. How do I do it? But then over time, this became really popular. And then I realized I'm spending my day putting on these forwarders. And I was like, this is too much. So surely we can do a better job. And the answer is yes. So we have a situation now where any user can deploy any forwarder in 30 seconds on any host inside the global network, okay? And let me show you a video on how that works. So let's have a situation where this is any machine on any host, okay? And we have /net access, so /NFS, okay? And we make a script, and we call it Splunk Live Environment.sh. Now, so they would CD to their environment, and then they would press enter, and then they're asked two things. What's the name of the new host, and what's your email address? Okay, so number one is Robbie Test. This is the name of the new host I want. It could be Big Bank in London, Big Bank in New York, okay? Then number two is I put in my email address because I need that to come through the home page because I need to know who's putting on these environments, okay? And then I press enter. Now, in 30 seconds, the forwarder is automatically deployed. The forwarder is now going to send data from that particular environment, from that particular machine, and it's going to go straight up to Splunk, okay? And that's pure automatic. And now, but we live in the action-reaction world. So if you do the action, the user wants to see a reaction. And you can see now straight away indexing, Robbie Test. So that came through straight away. So the user now needs to see, if they put on a new forwarder, they want to be able to see something happened in Splunk, okay? You don't tell them to make a cup of coffee and come back 2 days later. They want to see action, they want to see reaction. Now it's indexing because guess what? There could be 10 days of data there and it's all going up. So it's going to take Splunk a few minutes for that to index, go through some data models, and then it's done. But the whole point is that I don't have to deploy these forwarders myself. They do it themselves. With one script, it's all automatic, okay? So I don't waste my day. It's all about saving time so I can do other better things, okay? Now, admin spending too much time setting up new forwarders, let all the users create their own forwarders automatically. That was the solution, okay? By creating an accessible script. And that works very well. And now I don't touch it. I haven't touched it in years. It's great. I made it 3 years ago. Okay, data is only half the battle growing. Now this is a very funny title when you're at a big data conference and you're saying data is only half the battle. But they also touched on it today in the keynotes. Let's imagine you have a situation where you have an intern in the company and he's in 6 weeks and you give him 1 million lines of CPU data or network data. He has no idea what he's looking at. He or she has no idea. They just go, okay, it's just data, data, data. Like, I'm not a CPU expert. I do not know what this means. So it's all about pre-programming algorithms into Splunk that can analyze the data. Is there a problem, yes or no? So you have to then go around and talk to your experts. So in Murex, we have network experts, we have garbage collection, we have CPU experts. We employ clever people. I'm sure your company employ clever people. And also what can happen is, what happens if the clever person leaves the company? So all that knowledge goes with him. So you have to go out and say, well, I need your expert knowledge as the algorithm. So you understand the data yourself, you talk to these people, and then you put in the algorithm on top of the data. So I'm not a network expert, but we've network algorithms. So how does that work when we look at it? So let's imagine we have a situation where we're running multiple tests in parallel, okay? So Big Bank London, New York, Beijing, all running in parallel. Now we have our algorithms. Now we're going to use CPU network. They're just generic. Everyone understands them, okay? Performance tuning, etc. The KPI monitoring is on. The data goes through, and then bang, bang, bang. So we pick up issues. So let me give you an example. If the CPU goes over 90% for 1 hour, that's a problem. That's a simple algorithm, okay? And everyone understands that. The box is overloaded, okay? So, and then you get into more deeper ones with network, and then as your different source types get more complicated, you program in different algorithms. So what happens then? Well, they go all into the issue layer, and then you have a high-level overview. Now, it's a very simple high-level overview. The overview is literally green is okay, red is it's not okay. You have to make things simple, okay? Because people We employ, I say, 2,000 to 3,000 people, lots of experts. I can't be expected to be an expert in everything, okay? That's just simple. You cannot be expected to be an expert in everything, okay? Then what happens is you have a deep dive situation. So in this particular case, we've green, and then we've 1 for GC capacity, and then we've 16 for something else there. And now for the deep dive, you can click on them and you can go in to the garbage collection, the network, et cetera, et cetera. So anyone looking at a test, so say we're running a test for a stress test for a big bank in London, and all of a sudden you're trying to break the system. You're doing a Monday morning simulation when 200 new traders hit that new system, and all of a sudden the CPU goes 100% and goes flat. You need that to go red, okay? So, but then again, what happens? Let's imagine you're running that test Monday, Tuesday, Wednesday. It's a big long test, a big long system test. I don't mean a micro test. I mean, these are big system tests we do. You can also get a daily summary. So with these algorithms, we program to send out daily summaries because you might have been sick on Monday and you come in Tuesday. So you want to see, well, what happened on Monday? So you get a 24-hour daily summary of all these hosts with all the algorithms going through it. So you can then see what were the issues of yesterday's test. Now, you might not be interested in the German tests. You might be only interested in the London test, but it depends on what you're after, okay? Now, and then the algorithms just get bigger and bigger. So once you introduce this, and once you tell people that I want your source type, I want you to pre-program an algorithm, then what happens is it just keeps growing and growing and growing. So what does that look like? Well, so when someone logs in, it's very basic. They get a question of, well, what host do you want? We call it KPI monitoring. But then it's going to get lively very quickly. So they click one host. And straight away, we're going to run all those algorithms for the last 1 hour. So you get a real-time snapshot. How is my test doing for the last 1 hour? Red is bad, green is good. Okay, it's very simple. Now in this particular case, we have different types. We have generic algorithms, we have infrastructure algorithms. So you have all different sections of different algorithms that you have, okay? And you program them in. Now, in some cases, we might have a situation there where we have trades entering the system over 10 seconds. So we're a trading platform. A trade that takes more than 10 seconds is a disaster for us. So we have 500 of these trades. I want a high-level overview. So you click it, and then you get a very high-level overview. The trade booking, this is the trade ID, and then you can see these are the milliseconds it took, 76,000. The threshold is 10,000, so 10,000 milliseconds. And then you want to say as well, how did that look for the last 6 hours? Then you can say, let's do a trend analysis for the last 6 hours. So we've programmed it that it goes back in time, and you can see 2 hours ago there was 500 issues, and then there was 142 issues. So now you can see, well, has this been happening all day, or is this just in the last hour? So you do a trend analysis going back in time as well. But then if you're the expert, you also want to do a deep dive into the situation. So I've identified that there's a problem, and then I need to talk to the expert and say, hey, there's a problem. So I click it, and now it brings me to a deep dive dashboard. So the dashboard I showed you is very high level for anyone to use, but you also have to link it to a deep dive. So now the deep dive is here, and for example, you click on any one of these and you can see that you get a breakdown. Now I'm not here to introduce the deep dive dashboards. I'm here to introduce the concept that very quickly you understand, how is my system? How is my system? The answer is it's not doing good, okay? Because you might be normally looking at the generic algorithms, and on the right, you might see system health as 1. And that could mean, for example, you could have network issues, CPU issues, you could have problems elsewhere. So your expertise could be in one box, and your expertise mightn't be in one of the other boxes. But if you see it going red, you can then contact the team and say, hey, are you guys aware there's issues over here, okay? So what was the problem? Okay, giving an intern 6 million lines is completely useless, okay? He doesn't understand it, okay? You can't be an expert in everything. The solution, we created expert algorithms that sit inside that can be run on demand, okay? So now number 4, okay? A snapshot in time. Now this was one of the biggest things we developed about 4 years ago that got everyone really excited. So we're in the test and development scenario, okay? So if a tester finds an issue, he needs to tell the developer, hey, look at this. So the data's in Splunk, and he needs to say, I need you to look at this. Now, let's have a standard XY axis. So X is time, and Y is measure time. This is normal. Now let's go out on the Z axis. So we have host X, host Y, host Z. So these could all just be different banks across the world. And they're all hosted at Murex, by the way. This isn't cloud, this is on-prem solution. So I want to be able to communicate to a developer that I'm a tester, that there's an issue on the 1st of November on host Z. But what I don't want to do is tell him, hey, go to Splunk, press host Z, go to 1st of November, I think 12 o'clock. So I don't want to give him a list of things to do in Splunk. If you give him a list of things to do, there's a good chance to get something wrong, and then he's going to get angry at Splunk, and then Splunk is the problem, okay? What you want to do is make a URL that captures that, and with one click, that person, the tester, can send to the developer, and they can open up an interactive dashboard in Splunk. So let me show you how does that look. So let's go back to the KPI monitoring, and let's go to the garbage collection issue, the GC issue, okay? So we can see we had one issue here. We do the deep dive straight away. So let's imagine you're running a test, and a tester goes, oh, hey, there's a problem here. I need to communicate with the, so he clicks open the problem, and you don't have to understand garbage collection, but if you do, that's the problem there, okay? So the algorithm has picked up that there's a problem in the garbage collection. He goes, I'm not a GC expert. I need to get the GC expert to look at this. So he makes what we call a Splunk ID, and we just say bad memory 3, and we save it. Now we have a unique ID there, and also what we generate is a unique URL, and we copy the address. This address is now put into an email to the garbage collection expert, and they press enter. Within 10 seconds, they're now looking at the exact same problem that the tester has found. So the tester has found the problem, and then bang, 10 seconds later, the garbage collection, they're not looking at a screenshot, they're looking at the exact problem, okay? And it brings them straight to that problem. Otherwise, you had to give them a list of instructions how to get there. And that can cause issues. We found that people just got lost. So when you're working, you want to be able to kind of encapsulate where you are, the start time, the end time, the host that you're on, and then make it really easy. Make it into a one-click URL. So you're not giving a list of instructions for people to get to, okay? So what was the problem? Users had to click too many times to get to a known issue. So they had to give a big list of instructions in a deep dive dashboard. Developers were getting lost, experts were getting lost. It was causing a bit of aggro. Now, with one-click URL, you're brought directly to exactly what you were looking at. And that's now global. So that can be stored in the wikis, it can be stored forever. So when people are doing Slack, they can put in the URL, here, have a look at this, the problem's right here, and with one click, you're brought back to it. It just makes it all much more human. The reason I say that is because everyone has these mobile phones now. And in these mobile phones, everything is, when you're making Splunk, in my view, you have to make it to the level that you expect an app to be working at. Everyone expects an app to be perfect. So if you're making Splunk dashboards, and you're making a Splunk system, you have to have this thing in your head. It has to work really well. If your users have to really work at it to get information out of it, they're not going to like the system, okay? So it's kind of up to you guys to kind of really, and it takes a lot of effort to do this. It doesn't come naturally, and people won't thank you for it, by the way. You know, it's kind of thankless in a way. So like when you're developing your dashboards, you just have to be thinking, if I'm the end user, how do I make this easy for the end user, okay? So it's just all about in your head, basically. Okay, number 5, different users, different roles. So we had a situation where the admin user was doing everything. We were making new source types, new dashboards, creating new alerts, doing new lookups, and adding new forwarders, okay? We were doing everything. The reason was we were new to the company, and I was very eager to get everything working. So I was doing everything. About 2 years ago, our backlog was getting so big because we're becoming very popular, that I was like, surely we can get other people who are interested in Splunk to do some of this work. So we decided to make different users, okay? So one of the users we made was an edit user. So the edit user can update alerts, can update lookups, and can deploy new forwarders. So the whole point is we wanted people to help themselves, not to email me all the time saying, can you do this, can you do this? If you empower the users with a small bit of training and give them the rights, so they would log in with like an edit user right, their roles and responsibilities would change, then suddenly they're cloning 10 alerts that normally you would have cloned. They don't even come to me anymore. They clone the alerts for the new bank that might be testing on, and it doesn't come to my desk. So again, I've saved me time by empowering them. And they like this power, okay? The next user is the read-only user. So I've introduced both of these. They can now deploy their own forwarders. I talked about that. And also the Splunk Home. I gave them the ability to see the entire system from a high 30,000 foot level. So this was a way of empowering these read-only users, because up to that point, they were just looking at dashboards, receiving emails, and going to the alert manager. But now they can put on their own forwarders, and they go to Splunk Home, and they don't be emailing me all the time. So in a way, I've empowered these guys and these girls to basically help themselves. And the final user, which is working really well, is the new dev users. So we have a lot of Java developers at Murex, okay? And we have a lot of very clever testers in Beirut, okay? So we did a course. We started training them on how to develop in Splunk, properly develop good dashboards, okay? And what we did was, and to create new source types, and it took a few weeks to get this in, so it was an investment. And if you train 3 people in this, you might get 1 or you might get 2 who take it up. Certain people I find really take to Splunk, other people just don't take to it. It's kind of funny like that, okay? So what I found is we start training our Java developers, and effectively you're giving them the paintbrush, and you're saying, hey, you have a problem, why don't you go create dashboards now? And they create dashboards all inside the same app, and then we go and we take the expert algorithm I talked about earlier, and we plug it into our KPI monitoring. So it's a case that they're now developing dashboards, and we can see it, and it's going very well, okay? So we had the option of increasing my team or empowering the users. And in some cases, we decided to empower the users. So we have a champion in a team of like 5 or 6 developers. We've made him a Splunk champion or her a Splunk champion. And they now develop these dashboards. And of course, they come back to us with problems. And of course, we help them. Are they experts? No. But are they in the middle and they really like what they do and they get excited? Because, hey, guess what? If you're a Java developer, I'm sorry to say, sometimes you don't get a pat on the back enough. If you're a Splunk developer and you put up a cool dashboard, suddenly people are hitting you on the back, that's really good. And they like this. All of a sudden they realize, yeah, this is really good. They like this kind of praise. And they're showing their teammates, and now they're getting excited. And now they're getting more dashboards. So this is, we kind of found that these guys really, really liked it. So this is just a way of empowering your users, okay? So the problem, admin was spending too much time on bits and bobs. My day was being wasted just with little bits and bobs. How did I do this? We gave back some control, not all control. We didn't make it an open system, but we specifically created different users for different roles, and we gave back some control. This helped our day-to-day, okay? Now, number 6, nearly there, guys. Search party is nearly there. Okay, improving debugging by 10. So let's imagine we're running a simulation on a big bank in London, and let's imagine we have different trades coming into the system, okay? So a trade coming into the system, and the acceptance criteria is below X or below Z, depending on the trade type, different trade types. You might have, an IRDS, an interest rate swap, come in at different speeds, okay? Murex produces data in real time showing how quick the trades are going into the system. This data goes into Splunk. So let's imagine trades enter the system, X and Z. In these cases, they're below the threshold, okay? That's fine, we're all very happy. What if you get a trade that goes over the threshold? Normally in the test and development lifecycle, you go back to a day later or 2 days later to a developer and you say, hey, by the way, we had breaches in the test 2 days ago. Can you look at that? And the first thing a developer is going to say is, oh, I need debugging on. That means a tester has to rerun a test. And that can be not easy. If you're running a simulation over 10 machines, rerunning a test can be quite difficult. But let's imagine you could debug in real time. Let's imagine you've already discussed with the developers actions that's going to happen. If you discover you do a threshold breach, you're going to do a reaction instantly. In this case, it's a Java code, so we want something called JStacks and JMaps to be triggered. So let's imagine, as soon as you detect you have a threshold breach, you instantly trigger JStacks and JMaps on the Java JVM, so that when the developer goes to debug it, they have the information like 1 second after they picked up the problem. And they don't need to, you don't need to spend another 3 days rerunning a test, okay? So you automatically tell Splunk, run the .sh script on the remote machine and trigger the JMaps JStacks. Now, of course, and then the issue is found, and then the test is complete, and now the developer can now use the deep dive views to look at this data. So let's see how that looks. So let's imagine there's a threshold breach, okay? And we have a situation where the value is 10,024 and the threshold was 10,000. This is in milliseconds. So that's a problem. A trade was going into the system and there's a threshold breach, okay? And what we do is we put in 2 deep dive dashboards. So on the first deep dive is high level, and we click it and the developer can verify, yes, there was a breach. So they can see X is time, Y is measure time. These trades are quite high. It's over 10 seconds. There's analytics if I want them. This is a problem. But now, most importantly, the JStacks and the JMaps are also sucked into Splunk, and we've made deep dive dashboards for them. And now the developer can get JMaps, JStacks deep dive straight away that happened more or less as soon as the issue happened. So now what we're looking at here is a JMap histo. And I'm not going to get into the technical breakdown of this, but this is like how many objects were in the JVM, and this could have caused the issue. Is there a memory leak inside the JVM? Yes or no? The developer now has this at his fingertips, and we have all different breakdowns here, okay? So I'm not going to go into each of the dashboards. And then finally, we have the JStack. This shows you all the threads of the JVM. So maybe we're running too many threads. Maybe there's a deadlock. I don't know. But now at least, the tester did not have to rerun a test. The developer gets an email straight away, and the JMaps JStacks are sucked in real time. And within a minute of the issue happening, he's debugging. That's what you want. You want your developers to know there's an issue. You don't want them to look in 2 days later and then ask you to rerun a test. That's where you don't want in the test and development lifecycle. You want things to be crunched super, super tight, okay? And now, so number 6, rerunning a performance test is a waste of time. Debug in real time if you can, basically, okay? And we do all that with Splunk, by the way. So that's all done with Splunk, a real-time alert, triggering a .sh script that triggers a script remotely on the remote machine, which triggers the JMaps JStacks, okay? And it's all done with alerts, okay? Real-time alert in this case. Code versioning. This is the final number 7. I have to be honest, it's only this year we've started code versioning, and I'm ashamed to say it, okay? Because I'm not talking about backing up your data, I'm talking about backing up your app. So we make an app, and inside our app, there's our dashboards, our save searches, our transforms, our props, okay? I have done this in production. Now, we should have a beta site, okay? And we should have all this stuff in beta, where we do everything in beta, and then we go to production with incremental updates. But alas, we're human, and we all make mistakes. So naturally, at some stage, you're going to go to production, and you're just going to do a tweak, and you're going to think it's going to be fine. And I've done this in production. I literally I have a network dashboard, and I have a CPU dashboard. I have updated the wrong dashboard with a copy. So I have 2 CPU dashboards now. The network dashboard is actually gone. And you're like, oh my God. Now I'm in production. Splunk does not keep these. When they're gone, they're gone. If you overwrite your dashboard, it's gone. You can't roll back. There's no way to roll back from that, okay? The lookups you can roll back, you keep versions, but not a dashboard. So you have to be able to access your backup very, very quickly if you're in production. Or even if you just make a small mistake. You just need to know is, I have a backup somewhere. It makes me sleep at night much better, okay? So basically, and the backup does the dashboards, alerts, props, save, search. So how does that look? Well, it looks like the following. This is Murex. This is the app we have, okay? And inside Murex is something called local. This is where most of the data is stored, not data, most of the configuration is stored here. This is Peerforce. Every night we run a cron job to sync everything up from the app, okay? And now this is your save search here. So all your alerts are stored in that save search.config file. And if you overwrite a new, and then you can do the version, so 37 and 36. So last night I made a mistake, and bang, there's your diff. So you want to roll back or you want to do something else, you have to have this super quickly. Otherwise, like, you could be in hot water very quick if you don't have backup. So everyone just has to think about what are they doing for their code backup, okay? And of course, you can do the same for dashboards, okay? So it syncs everything. So I did save search there. This is a dashboard. You might have a small change and you can't figure it out. There's one small change. But that could take you an hour to find in production. Like, and then in this stage, your phone has gone crazy. So you need to be able to get back your code line super fast. So a lot of people use Git. We use PeerForce, and we find it good, okay? And I don't have to use it that often, but every now and again you do, okay? Now, coming to the end now, I promise. Okay, so we're all human, we all make mistakes. If you do not back up your code and you think you will not make mistakes, you're mad, okay? All that good work you're putting in, you have to back it up somewhere. As I said, it was only last year we started doing it, which was crazy, okay? And we used to have, say, KPI monitoring, and we used to do KPI monitoring _beta. And we do all our development in there, and then we'd map it over. But inevitably, you make mistakes. You're just going to make a mistake. And you have to know you have a backup somewhere, okay? So lots of people do different things. This is working for us, okay? This is working for us now. So the conclusion of these 7 is I've tried to bring them all together into 3 main topics, okay? Make it easy to use Splunk. If you're the Splunk champion at your company and you want people to use Splunk, and if your dashboards are clunky and not working properly and not one click and not, it's your fault, basically, to be blunt. It's like, Splunk is good, but it's like anything in life. You can make bad C code, bad Java code, you can make bad Splunk code, okay? You have to put effort into making your dashboards sexy, good, work, fast, okay? So I've just put that, so where is my data, fast forward a deployment, so they can deploy the forwards quickly, and a snapshot in time so you can send a URL to each other to make the whole system easy to use. It's all about making it easy for your end user. It takes a lot of work, by the way, and you mightn't be thanked, but that's what it is. The next one is show the issue. So data's only half the battle. That's the algorithms going through. Improving debugging by 10, and then code versioning. So if you have a problem, you need to get to the issue quickly. So it won't just magically come up with an SPL, right? You have to spend a lot of time that you can get to the issue and share the issue quickly, okay? And then the final one is empower the users. So this has worked quite well for us. We've trained some users how to use the system, and now they're generally happy, okay? So thank you very much for listening. I hope that's some benefit to what the power of Splunk can bring. Everything you've seen there, we've made ourselves, myself and a man called Ankit, who's back in Dublin, Ireland as well. There's 2 of us on the team. Everything you've seen there, we've basically made ourselves. So Splunk gives you the ability to make all that, okay? So I'll take any questions, if there's any questions. We have about 7 minutes, or maybe not. Maybe it's all perfectly clear. Sure.
So going back to you talking about your algorithms.
Yeah.
So it looks like you're handing it out to your own community of developers to develop.
Sure.
Those algorithms.
Yeah. Yeah, everything. So what happens is so the question is that about the algorithms and the developers creating the algorithms. So what often happens is that sometimes they're a Java developer and they make the algorithm themselves because they have actually learned how to program in Splunk. In other times, they don't have the time to learn Splunk, but they're an expert in the network or the CPU, and I would go in and understand their data, and I would understand how to program, and it would be SPL. So the search that's used in the deep dive dashboard is the same search that's used as a save search. And we call these core functions. So we save them. And the idea would be is that the search is referenced in 2 places. One is in the dashboard, and then one is in a save search, and then one will be in the KPI monitoring dashboard. So that what happens is that you call it, and then it drives basically from there. So in some cases, people are too busy, they don't do it, but it is SPL. It's all SPL, yeah.
So how have you grown that interest in your organisation for people to get out there and you're passionate about
Sure.
Support itself, doing a lot of the admin stuff, that's all right. And even before it was set up, what we did for me, and you managed to push on that now.
Yeah.
How did you get the adoption into
The expert algorithms.
to get them enthusiastic about developing their
Yeah. So just to recap on the question there, how did I get people to be enthusiastic about the expert algorithms? This is an ongoing battle, right? So when people start seeing the real benefits, they start coming to you more, and they start saying, okay, this is good, and we caught issues. So you start small, the low bearing fruit, the stuff that you know yourself, and then you get little micro wins, and then you just keep adding on and adding on and adding on. And it's actually tough going, because people you'd be surprised, I've done about 1,000 demos, and you just have to keep chipping away at it. So there was never one eureka moment where everyone went, oh my God, this is amazing, they all ran. That really came when the central testing of Murex has now changed to Splunk. So all our massive testing now, done by the team in Beirut, all that data goes through Splunk, and that's known as something called ORSAT. So when I won that battle, then the rest of the company came in line very quickly. So I won micro battles up to that point, like the Dublin developers and dashboards there, and then when I moved over to the main source of data for test and development, and that battle took maybe 1 to 2 years to fully win, because we developed the deep dive dashboards first, and then afterwards we actually developed the KPI monitoring, which is only a year old. It was developed by Anchor as well, actually. So yeah, I'd love to say it's an easy job. It's not. There's a lot of work to go into that, but that's the way it is. Okay, question there. Yeah, it's a good question. So the automated forwarder deployment, how do we do it? So we do it all inside the script. So let's imagine you go to machine X and environment Y. So say Lloyd Bank in London. Okay. The script is accessible via /net. So it's just a Unix script. And the first thing it does is it downloads a forwarder, okay? And in the forwarder, there's lots of just $, $host. And what happens is that the script will just do print working directory and store that as $1, okay? And then what we do is we replace $1. Now $1 is machine X London Bank, and then we replace that, and we have all the source types already ready to go. So in this, we have the config files already done, but they're all just XXX. And then what we do is we replace the XXX with the host, the new host. And there's just two things we replace. One is the name of the new host, and one is the name of the new location. And then we start it. It's actually not that difficult. It actually isn't. So and when people say that, they go, well, it's amazing. And I go, yeah, but it's not that difficult. You know what I mean? It really isn't. And then this empowered everyone to be able to do this. Now, we have other issues when people are inside firewalls, so we have to get some ports open, but 90% of people can do that. If you're inside a firewall, you have to just know what ports to open, and you have to talk to your security manager to make sure he's okay to open the ports, because you could be inside an SCZ or something like that. But it's still doable. So we take the data from everywhere, That's the way it is. Okay, thanks. Any other questions? Okay, thanks very much for coming, guys. Enjoy the search party, and we'll go from there.